All right, so my name is Valerie Henson. I'll stand over here. I work at my new consulting company. I specialize in I do systems programming consulting and specialize in file systems. But basically, I like anything that's hard. So I'm going to talk about storage for startups. In particular, how you can avoid spending money or running into problems. Is the feedback? Okay, I don't want to blow anyone's eardrums out. In particular, I'm going to talk about how you can not spend money on your storage and how you can be in control of it. And hopefully not have to hire somebody like me or pay support contract. The way I'm going to run this talk is talk for the 30 minutes about this topic. You can do questions in the middle of it, and then I want to do 15 minutes of question and answers. These are things I know something about. If you ask me questions about other things, it'll probably be less informative or funny. And I have my lovely assistants, Kristen Accardi, Megan Quist, and Danny Quist, who will be handing around cards and collecting them again. So just write your question. You can ask questions by holding up your hand, but you can also just write them down. And I will go through that. Okay. Okay. So you are a cool Web 2.0 hacker, and you have just created this awesome new service, which finds the right place to go to brunch on Saturday morning. And you are very successful, and you have lots of little users who come and are using your site, and that is very exciting. You're checking your web logs, and all that's great. But there's this very sad thing that happens, which is that these users cause your storage to catch on fire. If you weren't very careful about how to scale it, like for example, a lot of file systems are going to have one big lock on, say, a directory or possibly the whole file system, and you're going to end up getting down to like one request per second or something like that. So this is a point at which you're asking yourself, for example, what file system to use. And these are your employees, and they are all arguing. And they feel really strongly about file systems because file systems, for some reason, are religious, even more so than, say, distributions. So the thing you're trying to answer here is, which file system should I use? And this is something people think is very important and are really worried about and feel a great deal of angst and concern. And I'm saying that you should make the file system irrelevant. If your cool Web 2.0 application with all your great, happy little users is dependent upon a particular file system, I think you've already set yourself up for failure. So the way that you make the file system irrelevant is you try to you don't use features that are specific to a file system. So one obvious way to do this is so you take something like HFS for macOS. It's got all these great resource forks and cool things like that, or maybe snapshots on something like ZFS or a NetApp filer. You don't want to end up basing the way that your application works around these things, because then you're stuck. So what should you use? I want to go through a couple of things that startups should really put foremost. Like, so if you're a IBM or Oracle or some company that's already established and has a lot of money, or Morgan Stanley or somebody like that, you really can just pay for your storage. You don't really care how much money you're throwing at it. You can make it somebody else's problem. But this is a startup. You don't have money. So what you're looking for is something that's cheap, preferably free. But you're not going to solve this problem by going and buying a bunch of NetApp filers. If you can afford to buy a bunch of NetApp filers, you should go do it. But we're a startup. We don't have $50,000 right now. Another thing you care about is so the storage catching on fire problem. The thing you have to do with the startup is you have to start out small. You got to be cheap. You got to have something that just works, that one person can maintain, that you can spend $200 on and have it work. But you also have to have it ready to grow, ready to expand. So when the time comes, you don't want to be Friendster. I don't know if that was like a million years ago. Does anyone remember Friendster? Does anyone remember how it became unusable within like a year? and yet it stuck around and didn't die because people were like, my friends on Friendster. That was an example of just having a huge scaling problem. And this is very important, the hackable part. You, as a startup, you want to, if something goes wrong, you don't want to wait on anyone else. You want to be able to customize it for what you're doing. You want to be able to do it quick. You want to fast turnaround. So I think I have more on this one, next one. I don't. OK. I just wanted to talk really quickly here, coming back to the cheap aspect of things. There are a bunch of places to scale. There's this concept that a lot of people are familiar with, of pushing the ugly around. So whenever you're doing an application or building something on computers or many other things, you can simplify things here, but it usually means you're pushing the ugly somewhere else, right? There's a certain amount of the conservation of ugly. So kind of the question is, where do you want your ugly to be, and how much is that going to cost you? There's sort of this general rule. It varies some, but that the farther down the stack you go, the more money it costs to have your ugly there, to have your scaling happen here. So at the volume manager level, you can spend a lot of money and get SAN attached storage, and there's this huge cabinet, and supposedly it's easier, but you actually have to type in this big long 40-character name to get a disk. But whatever. But it's extremely expensive. A file system, clustered file system, some people here know a little bit about that. You can make a lot of money if you're a clustered file system company. Maybe not as much money as if you're like EMC and you're exporting giant disks, but this is people really want to put things in the file system. Don't do that. The file system is not the place to put your ugly. The file system is very important, very delicate, crashes the system if something goes wrong, loses your data. You really don't want to be doing anything fancy here. So. Database, this can really vary, but I mean, compared to a cluster file system, generally you can get something pretty cheap. But if you want anything that's reasonably performing, it's going to be hard to get something cheap at the database level. Application, that's what you're writing. You're already the expert. You're in control. You know how it works. And you wrote it, so it's only costing you your time. So that's usually a good place to do this. Does anyone have... I just want to repeat. Don't do it in the file system. So what I'm trying to say here is that I'm an expert in file systems, and I make my living doing file system stuff. And I really think that you shouldn't be doing that. So, OK. So one of the things I realized about this problem with everyone wanting to do everything in the file system and then having interesting scaling problems is, so you're sitting here and you're writing an application, and you realize, I have this great Unix file system abstraction. It's awesome. I have like arbitrarily sized files, it's just like a sequence of bytes, and I have directories, and I can put whatever I want in my directories. I've got hard links. I know I'm going to do a backup solution that uses hard links, so I don't have to, so I'm sharing my files. I don't have a new copy of every file. It's this wonderful, flexible, beautiful abstract interface that has survived for like 3 decades. And you really shouldn't use it that way. It's actually not... so file systems are still code. I recently shocked somebody by saying that there were bugs in file systems. Yeah. They're like, I am sure it was my script that was wrong, that was missing this directory on shares. Like, no, actually, I fixed that bug in 2 file systems, and Veritas refused to fix it. So you probably saw that exact bug. There's something about skipping directory entries when you're having concurrent create and deletes. And he was just crushed. Oh, my God. It's still code. It's very tricky code, too. So think of it as, imagine that you wrote it. And how would you write it? Would you write this incredibly abstract thing that performs well in every single case? No, actually, you're going to write it for the common case. This is the common case. So the best thing you can do when writing your little cool Web 2.0 application is to use your file system this way. And then your file system will never be a problem for you, because that's exactly the way what it was written for, and that's exactly the way that it was tested. The numbers are very approximate. Directories, you want sort of like medium-sized directories, just write directories. If you have 1 file per directory, you get this ridiculous directory hierarchy that's way too long and big. If you have a lot of file systems start performing very badly at Actually, just a little over 100. My home directory has something like 300 files in it. Slow. I need to go clean it out, but I haven't yet. That says something. 1,000, definitely you're going to see something in most cases. There are a number of file systems that have actually optimized for this, but there's a trade-off here. So one of my friends at a Web 2.0 startup was using XFS for a while because they wanted a simple application. They wanted to have 10,000 entries in a directory. And they had this issue where, sure, they could look up the entry really quickly, but deleting something took half a second. And when you have 20,000 users, half a second to delete a file is not okay. So they actually went and redid their application exactly this way to have only a few hundred files per directory. And they're using, I think they're using ACE2.3 now. File size, actually most of your files are less than 4K. If you go and look at your laptop or your server, you really want your file size to be in here somewhere. This is actually, you only want large files if you're going to use streaming access for it. If you're randomly accessing it, you should have them be smaller, but you don't want them to be tiny. You're going to end up fragmenting your disk. You're going to have a lot of directory entries, things like that. So stay in here. This is going to surprise most people. You really so your file systems can be a terabyte if you have the right patch set, but you don't want to do that. You actually do want to divide it up this way. It's a pain for management, and your sysadmins aren't going to like it, but you're going to be in control of how this works. You're going to have to migrate things around, but when things go wrong, you can actually fix it. Whereas if you're using some sort of fancy solution that pulls things together and makes it so they grow and expand and shrink, you're going to run into problems. And you're not going to be able to fix them. So directory depth, every time you look up a path name component, that takes time. You have to go to the disk, look it up, go to the disk, come back. They'll be cached at some point, but there's a limited size to that cache. Just read your files if you can. I know sometimes you have to actually write data, but you should avoid that. So writing is bad. That's where you get most of your locking contention problems. Metadata operations. So you shouldn't be writing to your files, and you shouldn't be creating your files, and you shouldn't be deleting them. You can do that. You should really try to cut this down as much as possible. The same person who was all crushed by file systems having bugs, I recommended that he's keeping directories around for a long time and creating and deleting entries in them. I recommended that he retire directories after a while, create a new directory, and then move all the entries to the new one. Basically, you're defragmenting your directory by doing that. You're sort of starting afresh, and that's a good thing to do. Sequential, or predictable at least, but sequential file read-write access patterns. Like compilers tend to like mmap things and write things in all different orders, and file systems are really unhappy about that. Since you control your application, you should try really hard to not be clever and just write sequentially. Okay. All right, so I want to talk about points of failure here, because this is, the rest of this stuff is about going fast and not being slow. This is about, our site was down for 2 weeks and we lost all of our users and our company is dead. So this is a little bit more crucial. So this is a random graph representing things that are important that interact with each other. And we'll say that this is one of our points of failure, and we're going to try to figure out what to do about this thing. So everyone knows that you should have few points of failure, redundancy, and all that kind of stuff. But I think something that's not emphasized enough is that the main thing you want for your points of failure is you want control over them. When something fails, you want to be able to fix it yourself right away on your time scale without spending money, because you're a startup. Time and money are really important to you. So here's an example. I host my stuff on DreamHost. There's this recent issue that DreamHost had, the big web hosting provider, pretty cheap, where they managed to get talked into a proprietary storage solution. They brought the price down to the point where DreamHost said, "Okay, sure, you're going to take away all our pain. You're going to scale for us. You know, we can grow our storage pool. We don't have to manage individual file systems. This will be awesome." Well, there's some issue. I think it was something like garbage collection, or basically it slowed down. It was taking people multiple seconds to get to their files, to get responses from websites. And Blue Arc did the normal thing and said, well, you just need to upgrade your operating system. That'll fix it. We don't know what's going on. It's like, okay, so if you have a mysterious bug and they say just upgrade, it's not going to fix it, actually. That almost never happens. So they ended up having this sort of months-long saga of users who didn't have mail access, didn't have access to their websites, and they really couldn't do anything about it. They tried migrating things around, and that didn't work either. And so basically, they had a point of failure. They had no control over it. They didn't even have access to the source. So another example of this is Joyent with ZFS. They ran a bunch of remote storage hosting services, and they had this fascinating ZFS bug, which had actually been seen. I went and looked at the bug records. It had actually been seen as early as 2004, and it was closed as not reproducible twice, because they're just like, well, I don't know. By the way, I worked on ZFS until 2004, so I get to criticize it. So Joyent sort of got lucky because they were a flagship use of Open Solaris and ZFS in particular. And so when their ZFS file systems got corrupted and were inaccessible, they actually got really fast on-site support from the ZFS development team. And it still took them 5 days to come back. And 5 days in startup land is an eternity. Again, they didn't. So this is something they didn't control. I've worked on ZFS. I recently went and looked at the code again. This is not something you're going to pick up in a few days. It's not something you're going to. I know who you can hire who's worked on ZFS. There's like 10 people, and most of them work at Sun. The other 2 work at NetApp, and then there's me. So it's not the kind of thing that you can be like, well, I've got a good programmer. Hey, programmer, go fix this. It's not going to happen. So. Okay. So I actually want to go back, but I can't. Maybe I can. I'll talk about this a little more. So I want to talk about open source, what open source really means. Because there's a lot of solutions out there that they're just saying, hey, this is great, you control it, because you have the source code, right? When you're a startup, what you actually care about is not, do I have the source code? You care about, can I pay people who know how to use this and who can look at the source code and fix it? So I end up talking to a lot of startups who are doing a storage product, and they're trying to decide, should I do Linux or BSD? And they usually want to do BSD because they want to have proprietary kernel modifications. And they really sit down and they think about it from the point of view of the technology and the license. And I always point out to them, there's the developer community. You need to think about who you're going to hire to do this, and whether you're going to, there's a big startup time for these things. So it's less about the source and more about, if you're doing a Windows application, you can hire a zillion Windows systems programmers, even though the source is not open, unless you have a web browser and can get to Russian websites. So yeah. Okay, so this is going to be sort of my summary slide of the trade-offs in the major file systems when it comes to being a startup, having control, having things be cheap. ext3 is my next thing. ext3 is, even if there weren't a lot of people who have worked on ext3, it's incredibly simple. It's exclusive of the journaling code. It's about 7,000 lines. Well, prior to some very interesting extra work. Really, you can hire a good systems programmer, have them sit down and understand ext3 well enough to fix a bug or a scaling problem. It just doesn't take that long. It's also extremely reliable. It's been around. It's been used a long time. The issue with ext3 is that it doesn't scale very well on a file system level basis. I suggest you just have a bunch of file systems and hire a sysadmin. You need to have good ops people if you're in a startup. So that's a place to push your ugly that you're in control of and that you can hire people for, and that is cheap. So XFS is an interesting edge case. XFS has one company that supports it officially, SGI. It's what they build their clustering file system on top of, so they care about it. There's money that's directly linked to XFS working. The interesting thing about XFS is that the people who have worked on it, even though they go on to do other things, just love XFS, and they work on it for the joy of it, for real. So, and you could they would love to work on XFS for you, so you can hire them if you really wanted to. It's also a stable code base. It's been around for a long time. It is actually a community project. This is one of the more successful projects that started out inside of a company and went open source. So, I've been trying to avoid the topic of RiserFS lately because you know I feel bad, and I spent a lot of time recommending that people not use RiserFS for many years, and then there's a part of me that's like, and I was right, but I've been trying to be polite. And then I decided I need to give you guys the real story here. RiserFS, wow, T means something, I don't know what. RiserFS was always, if you knew what was going on, you always knew that this was a bad thing. The funding model for RiserFS was new development. It was new features. So the way that they were going to continue working on it was to add new complexity and create new plugins and things like that. So I was working at a company, and I actually got in the email forwarded to me that Hans Reiser had sent to our company and said, hey, do you want to pay us $25,000 for the RiserFS undelete feature? And we were like, what? That was when the DARPA contract started running out. Originally, it was funded by government contracts. So that was a bad thing to know. The other thing you needed to know was that Hans Reiser ruthlessly crushed leadership and initiative inside of his company. So if anyone showed the slightest sign of wanting to do things or being a leader, he would punish them for that. So it really actually was a one-man show, and then the man went to jail, actually. He's no bail. I think the deliberation phase in the trial is going to start pretty soon. So you can talk about the bus factor. You can also talk about the on-trial factor for how likely you are to have something go wrong with your file system. So what I want to happen is I want ZFS to show up. Okay, I have no idea where the T came from. Sorry. So ZFS is something I worked on and is very cool and very well designed, and it's actually modern file system technology. I love using that word. It is open source. It's too complicated for almost everyone in the world to understand. And there's no file system repair tool. So really, when stuff goes wrong, you have to be a ZFS developer and have spent several years working on it. So if this does happen to you, you can call me up, but I don't think you should get in that situation. There's this trade-off between really smart and really hard to understand. You know, if you're just smart enough to write it, you're not smart enough to debug it, that kind of thing. So, hey, do I have any questions? I think we're ready to go. Okay, we can start.
So how big a company should one be before one uses ZFS?
So the question is, how big of a company should one be before one uses ZFS? Well, so this is a question of how much money you have to. It's where you want to spend your money. If you have the ability to make your storage be somebody else's problem by paying them lots of money, yeah, you should do that. How big should you be? I don't know how much support contracts run for Sun. I don't think you should be a startup. I think you should have been making money for several years, like a lot of money, like thinking about IPO money. So, yeah.
I guess you're saying ZFS is not cheap because when you get into trouble, it's expensive to get out.
Okay, so the point is that ZFS is not cheap because when you get in trouble, it's expensive to get out. Well, basically, it's not even money as an object. It's like, you have very few options for even fixing the problem. You can count the people who can fix your problem on your two hands. So, and I can fix it for you, but I would rather not. So, thanks. But I'll go.
The thing about ZFS is by the time you get the afford the storage that it's designed for, you're already making a lot. You're already buying massive amounts of storage that way. It doesn't make sense to run ZFS on everything.
Okay, so his point is that if you already have a lot of money, you don't need ZFS because you already spent a lot of money on your storage. Oh, okay. Okay, yeah. Well, so it's like when you can afford to outsource your problems, you do it. When you're a startup, you can't. So, okay. I'll do this one. Are there Linux file systems in the development stage that allow shrinking online? in the development stage. I think the code to make Btrfs shrink is either there now or in development, and will be there. So yeah, unstable.
XFS is in progress as well.
XFS is in progress. Yeah, so there's
actually a patch that does it as long as you don't have 10
yeah, so shrink is actually really super hard. It's one of the things I really like about the file system structure I've come up called chunkfs. So the thing about shrink is that you have to find everything that is part of the file system in a particular physical area of the disk. And usually this is really hard to do without walking the entire file system. Btrfs is going to do this right. It's going to have a sort of reverse mapping kind of thing. So that'll be better. But I think ZFS you can shrink. And that's about it. One of the things about basically, when people say they can shrink their file system, they're actually kind of lying. So, what about JFS? Okay, JFS is end-of-lifed by IBM. That was an unsuccessful attempt to take an internal proprietary file system and get it into the community and get it supported. And the JFS was pretty cool. It had a lot of modern file system stuff, and there's really nothing wrong with it. It was a failure of community. Thanks. Is ZFS better than Hadoop? I don't know what Hadoop is. It's a file system? Okay. GFS, but open source. ZFS is not a clustered file system. So GFS, the clustered file system. Oh, Google. One of the issues with file systems is that all of the letters are used. We picked ZFS because Z had only been used twice, and one of those times it was lowercase. So, yeah, so Google FS is awesome and cool, and it doesn't do what ZFS does. It's specialized for a particular workload, which is append mostly. So it's got this interesting record structure. They said, this is what we do. We create, we have producers which put records at the end of a file, and then we have consumers that come through and process them. And so we're just going to specialize for that. We're not really POSIX. We're going to have a user space library that you have to compile in a link against before you can use Google FS. It's not a POSIX file system. It's not a local file system. It's a distributed file system. So they're both awesome. So, ooh, Mike.
What are your thoughts on ext4? Is it churning? Is it not going to get it?
I'm sorry, what was the second?
What are your thoughts on ext4?
Okay, so ext4 will get you more than 1 or 2 terabytes in your file system. So the main important difference between ext3 and ext4 is that you have extents, and the extents are instead of the next block in this file is located here. The next block in the file is located here. You have 1 pointer per block. Extents, you say the next 5 blocks in this file are located starting here, contiguous. It's lots of things are extent-based. It's been around for a while. XFS is extent-based. And those extents are 48 bits instead of 32 bits. So you can get a larger file system. That's pretty much the main difference. And the main thing is that it's just gonna get you past the 1 or 2 terabyte limit. Sort of. There's a number of other things that need to happen, like file system check needs to go faster. There's a bunch of scaling issues that just increasing the number of bits in the block pointers is not going to help. I did do some work parallelizing file system check for ext2, 3, 4. And if your company is having issues with these and you have more than one spindle for your file system, you should talk to me. But yeah, it's not actually huge. So.
Can you say a few words about chunkfs?
Can I say a few words about chunkfs? Okay. Yeah, chunkfs is this idea that you want to divide your file system up into a bunch of little independent pieces that can be independently checked and repaired for the most part. So what you do is you create boundaries, things that are on the order of, say, 1 to 10 gigabytes in size, and then you write some wrapper code that glues them together again, so that you have your namespace is unrestrained and your space is shared between them. The cool thing about chunkfs is that it tells you specifically what your connections are between individual physical pieces of disk space. So you can, if something goes wrong in one chunk, you know how much it can affect the rest of the file system. We have a very short list of things that it can do. So it's a really good way to contain file system corruption. File system corruption actually happens a lot. It's happening more. Our hardware is actually getting a lot less reliable, especially with the various compact flash, solid state drive, all that kind of stuff. That stuff is really actually horrifically bad. Don't use it for anything that's important and not backed up. ChunkFS, I think what's going to happen long term is that the ideas are being incorporated into ButterFS, so it's more of a set of techniques. It is possible that it would make sense to implement sort of a hack on top of other file systems. So. I'm sorry, can you speak up? Sorry.
File systems we know love were designed for use of magnetic media. We're starting to see solid-state devices coming to the forefront. How do things need to change? Do they need to change for wear leveling or other types of factors?
Yeah, okay. So I'm going to start. There's a school of thought that says, wow, when we have solid-state drives, we're going to have seek time is going to be reduced by a factor of 10 or 100. So suddenly we no longer need file system technology. That word again. There's a bunch of really smart algorithms. That kind of one of the hardest parts of file systems is getting things laid out sequentially and predicting your access time. So seek times haven't really changed on disks in very much for the past 2 decades or so. Matthew Garrett actually got an Amiga Unix system from, how old is it? Your Amiga Unix was 90, sorry? 1990, so you had the physical machine. And there's this little disk test program that you can run to characterize your disks, and it came up with like 50, 60 seeks per second that it could do. Your laptop can do maybe 70 seeks per second. It's really not been a change. So yeah, optimizing for that moving to different parts of the disk takes a really long time is a huge part of file systems. However, there's a lot of other reasons to keep things sequential on disk. For example, your management, like the extent stuff, you can really reduce your metadata if everything's laid out sequentially. The other thing is that even with solid-state drives, there's still two issues. There actually still is a seek time for a lot of them. It's only a factor of 2. It's like the difference between reading a block here and then one randomly and reading 2 blocks that are together. But there's still some time to readdress and get the new data. The other thing is that there's per I/O overhead. There's always you have to go down the stack, you have to go through the little controller, it has to go get the block and come back. And that's per I/O. And if you can do one big I/O, that's still an advantage. So pretty much you don't, it just makes making things, it just takes away solid state drives and the fact that the seek time is much reduced takes away an extremely bad thing about file systems, but I don't think it fundamentally changes the way that you design file systems. You still want things to be laid out sequentially. So the second part, what was your second part of your question? Wear leveling. So this is very exciting. So Flash, you can write a limited number of times before it starts dying and losing your data, bits going to the wrong values. So everyone says, oh, that's okay. The hardware does wear leveling for you. Okay, so this is another case of pushing the ugly around and the fact that it's still code. And what's worse is that it's code that's written by the hardware manufacturers, random hardware engineers, and you have no control over it. So kind of what you're doing is you're asking people to do a file system that don't know how to do file systems, and you can't change it when you're doing wear leveling. You basically have to have this thing where you can move blocks around and have pointers to them. This is called a journaling file system, or sorry, a log structured file system. And actually, that's really hard. There's a couple of decades of research on this, and nobody can do it really well in software, even if they're an expert. So my feeling on SSD is that you really should just use a real log-structured file system on top of it. It's not just my feeling. I actually have clients and friends who have tried to use ext3 on Flash with wear leveling, and it breaks, and they lose their data really quickly in a matter of months or days. So it's not theoretical. There's a new log-structured file system called logfs. It's written by a very smart person, Jorn Engel. I think that's awesome. JFFS2 is your current choice, but it's fundamentally based on you have to read the entire file system before you mount, and you have to keep it in most of the metadata in memory, if not all of the metadata. So it's pretty much limited to about up to 64 gigabytes, and then JFFS2 is not your friend anymore. So I suggest giving money to Jorn Engel. All right, I think we have 5 or so minutes. Oh, yeah, Don.
One of the announcements on CFS is that it has its own built-in software RAID, its own LVM. Does it make sense for what we see in the traditional network model for file systems? You have a software RAID level and an LVM level, a file system level to persist or continue in the direction of CFS.
Yeah, so how should things be layered? Is squashing them together good? Is it bad? There's a growing consensus. So here's the old day. You had a disk and you had a file system, and they talked to each other. And they had this interface. It's the block I/O interface. And you said, give me block number blah. Read it. OK, now write block number blah. And that was great. And then you had this thing where you wanted to do something fancy like mirroring, and it seemed really smart to just say, I know it, I'll pretend I'm a disk, and I'll give the file system the same disk I/O interface, but down below I'll replicate it out to disks, or I'll do RAID or something like that. And this is the logical volume manager. So you had 2 levels of the same interface, and what you do is you lose information when you go through the block I/O interface. All you know at that point is I want to read or write the block at this address, and it should contain this data. When we did ZFS, we looked at this and said, well, you can do all these crazy, cool optimizations, which are actually very simple, very smart, improve your performance a lot, allow you to do a lot smarter things. If we had more information between these layers. There's a lot of research going on in this area. It's like gray box and various things like that. The extreme is OSD, object storage devices, which I don't think is a good idea. You're like, hi, I'm generic objects, and I'm going to do generic objects for you however you're using them. That's a little too far. But if you have the information of this block is allocated, and you have a virtual address system, it's like, and we learned from memory, we're like, hey, physically addressing things is bad. It's really, really convenient to have a virtual address and then convert them into the physical address. And I can put my memory wherever I want now, move things around. Same thing with disks, actually. You want to have a virtual address to do these things with. So if you have a virtually addressed free allocate interface to your volume manager, you can do a lot of really smart things, like not mirror blocks that are freed. If you're doing mirroring at the block level, you have to have like a dirty bit set, and you can't return until you've written both of the blocks, and just a lot of you miss out on a lot of optimizations. The ZFS software RAID is very smart and eliminates some consistency problems and holes where you can corrupt your data. And harder RAID, again, because you have the information of this block is not referenced yet. So I know when I need to have everything consistent on disk in the RAID system. So, and I think there's a growing consensus that this is the way to go forward with file systems. There's still resistance, but I'll bet on it being everybody agrees with this. I think this is one more question. We're done.
Following on to that, do you think there's a way to preserve that sort of layered interface and make it richer so that you can do these optimizations?
Yes, man, isn't this going to make things worse that we have like all of these, we're squishing everything together and we're having a layering violation, all that great stuff. Actually, you have a better, stronger, it's still an interface between the disk driver and the volume manager and the file system. They're just better interfaces that have more information. Very strong, very good interfaces. There's no bad layering. You get to have your cake and eat it too with this structure. Okay, I've talked long enough. Thank you very much. And I'm going to be assisting Kristen Accardi with her writing a device driver in 30 minutes top tomorrow. I think it'll be a really good time. We're going to actually try to write a device driver in 30 minutes, sort of. I'm typing. So it'll be great. You should come. 12:30. Thanks.
While you're being debriefed,